The revelation about Jupiter's weather system and its evolution are not the only new knowledge we have of the planet's core. After the Sun, Jupiter has the strongest magnetic field in the solar system, and it causes some fantastic aurora. They're mainly driven by particles emitted by Jupiter's volcanic moon, Io, interacting with that magnetic field. But curiously, these aurora vary in colour, and at each pole, they are different shapes. Last time, Chris met with Jonny Nichols, who studies them.
If there was one thing that you could find out about Jupiter, you only get one answer to a question from the Juno mission, what would it be?
I want to know what is causing this. I really want to find the answer. What is giving us all of these sparkles and flashes and pops going off here?
Today, I'm hoping to find out just what's been discovered.
This here is the auroras on Jupiter. This whole area is about 3 times the size of the Earth. Gives you the scale of the system that we're looking at. Now, to show you some more detail, these are some more images that were taken by the Juno spacecraft.
Oh, these are snapshots?
These are snapshots taken each time the spacecraft flies over the pole. And here we're looking at a map looking down onto the North Pole. So these auroras were taken in the ultraviolet. Now we're shown here in the optical, of course, so that we can see it. The red shows us where particles are hitting the atmosphere with a lot higher energy than the white. And what we've been doing is trying to figure out why these different regions have these different auroral colours.
But it's not just the varying colours that are unexplained.
If Jupiter's magnetic field was just like a bar magnet, if you remember the iron filings experiment from school.
Or like Earth's.
Or like Earth's, then Jupiter's auroras would be round, just a nice perfect circle. Now what you can see here is that actually the shape of the auroras is more like a kidney bean.
So what happens at the South Pole, and is it similar?
This is a Juno's eye view of Jupiter as it flies over the planet.
Oh wow.
And you can see the northern pole here, and the northern pole has its characteristic kidney bean shape. The south is much more circular.
Yeah, it is. So quite different.
Very different.
Do we know what's causing that?
Well, that's telling us that the anomalies which are distorting the magnetic field in the north, which are causing the kidney bean in the north, are not present in the south.
The anomalies in the visual evidence suggest the magnetic field varies around the planet, something that's supported by remarkable audible evidence as well.
What we've got here is radio waves beamed from Jupiter that have been picked up by the Juno spacecraft. The particles barreling down the magnetic field just before they cause the auroras emit radio waves into space. And this is what we're going to hear.
So you're taking the radio waves emitted by Jupiter and converting them into sound?
That's right, it's radio waves that have been turned into sound. The frequency's been changed so that we can hear it and understand it.
That's really quite eerie. It feels as if it's come out of a 1950s science fiction movie. If someone was looking for alien life on Jupiter, hearing this, I think they'd believe it's there.
That's right.
But what modulates it? What causes the change in frequencies?
The frequency change is caused by the changing strength in Jupiter's magnetic field, and that's telling us that Jupiter's magnetic field is distorted, and that's one of the things that Juno has been finding. The further the magnetic field is generated from the centre, i.e. the nearer to the surface Jupiter's magnetic field is generated, the more lumpy it appears. So most of the magnetic field has probably been generated deep in the core, but there is some component of it that has been generated nearer to the surface. The energy is there, the electrons are there, but then they don't look like we expected. And so we've been scratching our heads to understand why Jupiter's auroras, the processes that are causing Jupiter's auroras, are more diverse than we thought.
Well, Jonny, it's been a fascinating journey.
Absolutely.
Thank you.